Okay, and I believe because today most of you are coming to the class, so I don't need to give you the attendance code. Okay, so let me go through the. Okay, okay, thank you. Okay, yeah. So we are in chapter 6, the volume of solid revolution, and remember that the key points or the important one is by looking at the this shape. Okay? We call this the disk. Okay? So sometimes we call the method to find the volume is we call the disk method. Okay, and you can have the disk in terms of uh, dx like this, okay? Dx, or you can have in terms of dy like this one, dy. Okay, so the important thing here is this is a cross section area, right? This is a circle. So the area of circle multiply with the height, which is dy, and we add all these slices from end, the first endpoint to the second endpoint, okay? And we call those method, and we are basically integrating the endpoint, okay? And then the functions will be the area of the variables. For this one is variable of y, and then multiply with the height dy. Okay. So it can be dy or it can be dx. It depends on the curve, depends on the shape, right? Okay, let me give you more examples, okay, on how we can look at the method. Okay, if we have the region R or the region S, okay, bounded by curves y equal x, y equal x squared, and rotated about the x-axis. Find the volume of resulting solid. So to give you a better idea, first maybe you need to draw the curves y equal x and y equal x squared, see the intersections, and imagine how the area will be rotated. Okay, okay, let's draw this curves. Okay, let's say this is our y equal x squared. Okay, to know the intersection, we can check the equations. So we can equal both x squared equal x. So we can have this. So this is 0 and 1. So this is 0 and this is 1. Or to be precise, this is 1 point, and this is 0 0. Now the area is in between these two curves. So this is the area S. And then we need to rotate the area to the x-axis, this one. Okay. Okay. Now the S region here, if we look on how it's rotated, then we can see that if we take some rectangle of dx in this area, and imagine this being rotated here. Okay. So imagine we have if you want to make a shadow of what this look like, probably like this, okay? And the image becomes more or less is looking like this, okay? So it was having the, so inside here is there is a hole, right? A hole. Okay. Now the area becomes, so if we have, this is the radius, let's say radius 2, this one is radius 1. So simply this is the area. So this is the area of x because we are using dx. This will be the area, the first one, pi r2 squared minus pi r1 squared, right? The total area that we have now. We can also write this. Or we can write in terms of, in general, this is pi outer radius minus pi inner radius. So we have this pi, and this was the x, and then squared, minus pi. This is x squared squared, right? And again, the idea in all volume problem is identify the radius. Okay, identify the radius. Once you have identified all the radius that needed in the calculation, the calculation itself, the integral, is not, it's not difficult. It's pretty simple calculations. Okay, so the volume is integration from 0 to 1 for the x value. This is ax dx. Or we can write directly, we can write this become x squared minus x to the power of 4. So we can write this becomes 0, 1, and then this will be pi x squared minus x 4 dx. Okay, and we can solve this and integrate this become, and then input 1 and 0. This will be 15, 5 minus 2, 3, so 2 over 15, 5. Okay. Any questions? Any questions? I think still okay, right? Still okay. Okay. Now, the difficult part or the complication starts when the center of rotation is not x or y, but rather line. For example, y equal 1, y equal 2, x equal 1. You need to rotate through or about that line. For example, let me give you another question. Find the volume of solid obtained by rotating the region S. This is the previous example. About line y equal 2. So region S is in between the y equal x and y equal x squared. So we can draw the similar let me draw this. So let's say that is our region. Okay. This is region S. Okay. And I think I need to move this a little bit down. I'll move here and give this a little bit higher because we know that this is 1, right? The 2 is here, 1 is here, and maybe 2 will be here. Let me erase this. This is y equal 2. Now the rotations is centered at this y, okay? Y equal 2. So we need to rotate from here, rotate to there, okay? So we taking this angle. So we have a large shape with a with hole in the middle. you have a large hole, right? So we will have the radius is so we have two radius. So this is the radius that is inside, and this is the radius or outer radius. And let's say this one R2, this one R1. So the radius is let me just write in terms of R1 and R2. The outer radius is the green curve here, right? Until here. So we have this is x squared, right? So let me write here to give you more idea. So this is x squared, right? This is y, right? Y, or in terms of the green curve is the x squared, right? So the total radius is, we have 2 minus x squared, right? Okay, the R2. So let me write here. R2 is 2 minus x squared, okay? And R1, this is until the blue curve, okay? This is, we have x, right? This is x, so 2 minus x, okay? So 2 minus x. That is our radius. So the area will be pi 2 minus x squared okay, minus pi 2 minus x squared. Or we can rewrite this okay, we can expand this into the expansion form. We squared this 4 minus 4x squared minus x squared. Okay. So we have the volume, same same construction. So from 0 to 1. And let me write the pi outside here and put in the x to the power of 4 minus 5x squared minus 4x and then the x. And we can simply calculate this. From 0 to 1. So we may get pi 1 over 5 minus 5 over 3 minus 2. And we can compute this. Right. Fine. Um, six, 3. Is 8. This one. Oh, yeah. Oh, yeah, correct. This one. Okay. So this should be 11 plus. So this is 1, 5, 3, 3, 15. Let me check one more time. So this is 6 minus 5, 1 over 3. Plus 3, 5, 8. Oh, yeah. This should be 8, 15, 5, right? All right. Okay, so I think this is enough examples for the disk method. Okay, so the disk method. Okay, let me summary of this method. Okay. We'll take some notes here. Summary of volume. So first, if I have a y equal f of x, this is from A to B, okay, and you have rotated. You want to find the volume in between this f of x with the x is from A to B, rotated through this x-axis. So you have this shape here. This is dx, and the volume is integral from A to B. Now this is y, that is f of x, and this will be pi f of x squared dx. Okay. And secondly, we also have let's say that part. Let's say this is C and D, and now it's rotated about y-axis, and this function, this is x equal g of y, so function of y. So we are going to have dy, okay, we have dy here, and we have the shape here. And the volume will be integral from c to d pi and g of y squared dy. And this x equals g of y. Okay. Okay, now from this two summary, I think um, can have at least a general formula for the volume, either in a function of x or function of y. Okay. And sometimes the curves can be, or the volume can be solved by these two methods, and you can choose which one. But sometimes there is only one way to solve it. Okay, last section here is just to illustrate, okay, what's the weakness. Okay, let's draw the functions that is y equal 2x squared minus x cubed. Okay. If you draw this in the graphing calculator, you'll get that this will result in something like that. Okay, if you want to rotate this, okay, and you want to know the area here, okay, this is the area that you want to compute the region. So this is the, let's say this is the rectangle here, or maybe the rectangle is about that way. So this is the y, this is the x. Okay. Either way, when you try to rotate this or rotate this one, if we are going to use the disk method, okay, when you try to make the disk itself, there will be a little bit weird shape, right? Okay. If you imagine how it looks like. So this is 0, this is 2. Okay, so if you rotate through the y-axis, there'll be so let me check this. Okay, so if you have from here, let's say here, to make it easy to follow, okay, let's say this is our dx here. If this is, let's say this is our r1. Okay. If you rotate this, okay, and we this is how it's supposed to be, how the volume is supposed to be. And it is like this, like this? No, right? If you imagine the whole thing here to be rotated, It's not a disc, right? It's like when you wash your hands, okay? Sometimes the shape is looking like that, or washing hand in maybe in the washroom, right? Okay, something like that. If you have like this shape here. So sometimes this is called the washer method. The washer method. How to solve is we call this a washer method. Or the more famous one is this is a cylindrical shell method. Okay. So we are not going to use the disk. We are using another method that I will tell you more next Monday. Okay. So we will try to solve this one. 2x minus x, 2x squared minus x cubed. Okay, we try to solve the region enclosed by this, the x-axis, and this from 0 to 2. Okay. Okay, that will be the next Monday. Okay, so do you want to start the quiz first, or you want to know the midterm result first? Huh? Quiz first? Agree? Quiz first? The time limit for the quiz is more or less is around 40 to 45 minutes. 40 minutes, 45 minutes. So if we start now, then 40 minutes later, I'm collecting the quiz and I will give you the midterm. Is that okay? Or you want to know the midterm first? Check the score? Because I will let you know about the if you get maybe not really good, I will have you chance to have a make up exam. Okay, make up exam. Okay, and let me talk to. Okay, so Maria, you are joining online. So I will stop the online class because we will have a quiz. I will let you know for your session. Okay, I will email you later for the schedule for all the exam that we have.